Hello everybody, today I'll show you how to make a minimap in GTA style. Most Unreal Engine tutorials that show you how to make a minimap use just a scene capture component over your character and call it a day. This method isn't really good because you're rendering the scene both from the perspective of your camera and from the perspective of the scene capture component. It's better to make your minimap with an image. That's how it's done in GTA as well. As you can see, I have a rendered image of my map, and I have another example similar to the racing games. Let me change a couple of options here. Now let me show you the other minimap. This is more like the type of minimap that you get in racing games, that it only shows the road that you're driving on. They're both done in the same way. You're using an image and some math to calculate where to place the image and how to rotate it. I'll show you how to make both of them. It's really simple and it doesn't use additional resources to render the scene like the method shown in most of the other tutorials. Okay, let's start. I'll delete everything and recreate it. I'll just leave the images that I imported. Let me just clear also the level blueprint. And now you can see that we are starting without a minimap, and we'll recreate everything that you saw before. You need to start by creating a scene capture component just to capture a reference image to draw your map on in Photoshop. So click on the Add to the project button and start typing scene capture and choose scene capture 2D node. Here place it on 0, 0 location, and for the Z value choose a high number that's higher than everything on your map. Choose orthographic view, and the width we'll set later when we have the texture to see how much of the map we are currently seeing. Next step is create the render target. It doesn't really matter how you call it because we'll delete it anyway. Drag it to the texture target of the scene capture component, and if I open it, you'll see that the scene is being rendered inside. I'll increase the orth width. For this project I know that 185,000 it's a good value. I forgot to rotate the camera minus 90 degrees in the y-axis to look down. Now you can see that the full map is visible in the render target image. We can increase the resolution to 2K in order to have more detailed map. Let's save this. And now what happens if you don't have the Z value high enough? If I put it on 100, you'll see that everything on the map that's above 100 units, it's now being cut from the render. So make sure this value is high enough to show everything on your image. And now you can export this render target image by right-clicking on it, Asset Actions, and then Export. It will prompt you to save the image as a file. Save it. I already have it. Then open it in Photoshop, and you can draw your map on top of it. I have one image that is just the render of the map, and one image that I traced all the paths in white. This will be used for the opacity map for the racing style minimap that I showed you earlier, and the other one will be the more realistic rendered map. You can have any image that you want. You can have simplistic representation with just shapes or rendered, or you can draw anything additional on it, name of towns, anything you want on your map to be shown. Doesn't really matter. The important thing is that you have an image at the end that you want to use. Let's continue in Unreal Engine. I have imported both of my maps. I also created one circle that I will use as a border around the map, with a cutout on top that I'll place the north sign as you have in GTA, and one arrow that will represent the player position on the map. That's everything you need to start doing the minimap. First thing that we'll do is a material parameter collection that we'll use to drive the position of our minimap. So go to materials and choose material parameter collection, call it material parameter collection minimap, and inside you will need 4 scalar parameters. The first 2 will be the X and Y coordinates, the third one will be the zoom level, and the final one will be the dimensions of the map. This will be the same number that you put in your scene capture component. Now you can see that it's 185,000. Put the same number here, and for the zoom let's start with 0.1. The X and Y will default to 0, and we'll change them based on the character movement. This is everything you need in the material parameter collection. Now create the material that will show the minimap. So create a new material, call it M Minimap. Inside the material, change the type to user interface, and I'm using a translucent material to have the opacity. You need the material parameter collection here, and you start with the zoom. You multiply the zoom by the texture coordinate. This will control the scale of our texture. So multiply. Then for the math that will drive the location of our character, you'll need to follow the steps, because it's really hard to show what every node is doing here, but I'll try to explain why we are doing it. You use the Y and the X coordinates to change the position of the texture, but you need the value to be between 0 and 1. That's the coordinate space for all textures. So divide the position by the dimensions. We'll do the same for the X coordinate, and this will give you a value between 0 and 1 for each of the coordinates. For the X value, we'll actually need to invert the position, because moving on the map and moving on the UI screen are the inverted positions. So we'll multiply this by -1. We'll divide by 2 our zoom level. As I said, it's a little bit hard to explain now why we are doing this math, but it will be easier when we have everything connected to see what it's doing. We'll divide our zoom level by 2, and then we'll subtract it from 0.5 in order to center our position, we'll add our coordinates to this center position, and then we'll append vector these two positions in one vector, which we'll need to use with this result of the multiplication of the texture coordinates and the zoom level, and this will determine the position of our texture. Let's put our texture here. This will be the rendered map. We'll start with it. You don't need the scene capture component anymore. I can delete it. You don't really need the render target as well. We only used it to get the reference image. So let's clean everything up now. And now we can add the results of our calculations here and use it for the position of the texture sample. If I disconnect it, you'll see that when it's connected, the map is centered, and we start at the 0, 0 coordinates, because this is what we have for the X and the Y. I'll just show you in Photoshop. If you use the rowers to show the 0 position of the map, you can see it's just on this lake, and you see that this position is represented here on the center of the lake, and the zoom level is applied correctly. That's why we have the map zoomed here. Now connect this to the final color, and you can see that our minimap is showing here. To make it more interesting, I decided to have it in a circle. To make the opacity mask for the circle, use sphere mask, put the radius to 0.5, the hardness, let's say, to 90. Let's have a little bit of fall off at the end. Use the same texture coordinate node here, and we need a 2 vector, so hold 2, click anywhere, and our vector will be 0.5, 0.5. We'll connect it here, and now if I connect it to the opacity, you can see that it's masking our map in the circle. For now, let's have it that way. To start with this type of rendered map, and later I'll show you how to change it to the other type if you want to. This is everything for the material for the first type of the map. Now we'll create the widget to put the minimap in. So create a user widget, call it widget minimap. Now in the widget I'll stack a couple of components. Let's change from fill screen to custom and put 250 and 250. That will be the size of our minimap. Put first one canvas panel. Inside our canvas panel we'll have an image. Put the anchors to all the 4 corners, change the offsets to 0, and change the brush to our m_minimap material. And you see that our minimap is already shown here. Let's add a text block. We'll use this for the north indication. So change the anchors to top middle, change the position to 0, change the alignment in X to 0.5. That will align it by the center of the text. And we'll put just an N for north. We'll choose a font size of 20, and we'll center the text in the middle. This should be fine. And now let's put our circle as well. We'll change also the anchors to the 4 sides, and we'll remove the offsets. This way it will always fit the size of the canvas panel. Now let's rename our canvas panel to some better name. So let's call it a panel. Mark is variable. We'll use that to rotate our panel based on the character rotation. You'll see that here we have the transform angle parameter, which will rotate our minimap. The last component that we need is this arrow, but we'll place it in the other widget that will hold our minimap inside, in the heads up display widget. So compile and save this, and let's create the other widget. Let's make another user widget, call it widget heads up display, and inside this widget create again a canvas panel. Then in the user created, find our minimap, place it inside, change the size to 250, 250, change the anchors to where you want your map to be, and the position offset to the position that you want your map to stay on. Let's say I want it here. And then place our arrow, choose the same anchor that you have the minimap for our arrow. So bottom left for me. The position will be set for the center of the arrow, and I'll have 175 for my arrow to be in the middle. I'll reduce my size X until I like it. I think that's fine, 20 by 25. This should be fine. Compile and save. And now into our level blueprint, we'll create widget. The type of widget will be W_HUD for heads up display. And after we create the widget, we'll add to viewport, and we'll connect this for the target. We'll need the owning player connected here. Get the player controller. This is everything you need to add your widget to the viewport. And if I press play, you'll see that our minimap is now on the screen. It's not showing our position, it's not moving, and it's not rotating, because we didn't create still the logic for this. But this is quite easy. Enter in our Minimap widget, change to the graph view instead of the designer, and on the event tick we need to update our X and Y position and also to rotate our widget. To do that, set scour parameter value. We use our material parameter collection for the minimap and the parameter X and also the parameter Y. And to set those, we use the get player character, then get actor location. Let's split this pin and put the location for X and Y to the corresponding parameter value. And next we'll get the actor rotation. We'll split this pin and we'll use it to rotate our panel. Let's use the set render transform angle function. and we use the Z value from our player character rotation. Let's compile and save this. And if you play your game now, you'll see that you have the position updated. Actually, the map is rotating the wrong way now. Let's change that here. We need to multiply our rotation by -1, and that should be what we need to properly reposition and rotate the map. Okay, this is great. It works as expected. This image, as I said, you can have whatever you want here. You can do everything you want in Photoshop, just save it as an image in the end. In my case, I have the other type of map that I like for racing games, for example. Let me show you what you need to change. In the material, you use the other image as a mask. In order to have also the sphere mask, you just multiply the two together. Let's just use one of the channels. And for the cover, you use the 3 vectors, so hold 3 and put 1 for each value to have the white cover. And you don't need this texture. I'm using the other texture as an opacity, and my cover is solid. You can have image as well for the cover, just this image is not really suitable because it will blend too much with the background, so make some better image where you cover the different parts in different colors, for example, whatever you want, but put your image into the final color, and the opacity map can be a different image. And this will be the other type of the minimap. Let's check now if we hit play. Okay, it seems that it works fine. For this type of minimap, I actually like this hardness to be lower, so let's set it to 50. And you see that now the map is fading a little bit more in the ends, and you can see better the north sign. You can change the zoom level in the material parameter collection. If you make the number bigger, the map will zoom out. If I have it to 1, it will show the full map inside the widget. It will not be zoomed at all. You can see that this is the full image that we created, so it's not really useful for such a big map to have such a small image. And if I have it really low, like 0.01, you have the map really zoomed in. And again, it's not so useful. You don't really see where you can go. Depending on the size of your map, this will be a different zoom level. For me, 0.1 seems to work fine now. And this basically everything for this minimap tutorial. It doesn't re-render your scene all the time like if you're just using a scene capture component. So it's really better for the performance, and also you have the option to have different styles of minimap depending on the image you create or the material that you set here. This will be everything for this tutorial. If you have any questions, please write in the comments. You can subscribe and like for more tutorials like this. I'll try to make the next one sooner. If you have any request, please write in the comments, and see you next time.